Namaste dear students. I am B.G.Shinde sir and we are discussing chapter number 1 units and measurements of 11th physics. We have discussed dimensions, we have discussed errors in measurement, estimation of error up to lecture number 11. Also we have seen numericals, we have seen examples which are related to those topics. Today in lecture number 12 we see the topic significant figures and order of magnitude. Dear students, listen this lecture up to end. Also tell your friends about these lectures and share these lectures to your friends so that they can study at home. Purpose of these lectures is only for the study of the students at home, and so you share these lectures to all the students so that they can study. तर सर्वांनी लेक्चर शेवटपर्यंत ऐकून आपल्या मित्रांना हे लेक्चर शेअर करायचे आणि प्रत्येकाने सबस्क्राईब जर केलं तर जो नवीन लेक्चरचा व्हिडिओ असेल तो तुम्हाला ऑटोमॅटिक तुमच्या यूट्यूब चॅनलवर बघायला मिळेल. तर आज आपण बघू लेक्चर नंबर 12 मध्ये सिग्निफिकंट फिगर्स. सो व्हॉट इज सिग्निफिकंट फिगर्स? द नंबर ऑफ डिजिट्स इन द मेजरमेंट्स which are about which we are certain plus one digit about which we are not certain, we are uncertain, that is called the significant figure or significant digit. म्हणजे काय? नंबर ऑफ डिजिट्स अबाउट विच वी आर सर्टन, म्हणजे एखादा मेजरमेंट आपण लॅबमध्ये घेतलेलं आहे आणि त्या मेजरमेंट मधले जेवढे अंक असतील त्याच्याबद्दल आपण खात्री राहील किंवा सर्टन राहू, आणि प्लस एक डिजिट असं असेल की त्याच्याबद्दल आपण अनसर्टन, शेवटचं डिजिट असतं ते लास्ट डिजिट विच आर अबाउट विच वी आर अनसर्टन, that is called a significant digit, that is called a significant digits or significant figures. म्हणजे सर्व सर्टन आणि अनसर्टन हे सर्व डिजिट्स, सर्व नंबर्स मिळून जे असतं त्याला म्हणायचं आहे सिग्निफिकंट फिगर्स. इट इज कॉल्ड अ सिग्निफिकंट डिजिट. फॉर एक्झाम्पल, सपोज दॅट इन लॅबोरेटरी वी मेजर some distance between point A and B by using the scale of least count 0.1 centimeter. म्हणजे एक मीटर स्केल घ्यायचं आणि त्या मीटर स्केलने किंवा एखादं स्केल घ्यायचं त्याच्याने अंतर मोजायचं आणि ते जे अंतर आहे ते मोजताना स्केलचा जो डिस्काउंट येतो 0.1 सेंटीमीटर असेल. डिस्काउंट इज 0.1 सेंटीमीटर. नाउ व्हॉट इज डिस्काउंट? डिस्काउंट इज द मिनिमम मेजरमेंट मेजर्ड बाय एनी मेजरिंग इन्स्ट्रुमेंट. कोणत्याही मेजरिंग इन्स्ट्रुमेंटने जे कमीत कमी जे मेजरमेंट घेतलेलं असतं किंवा घेता येतं त्याच्याने त्याला म्हणायचं आहे डिस्काउंट. डिस्काउंटला एनसीने डिनोट करायचं. म्हणजे आपण नेहमी जी पट्टी वापरतो त्याचा डिस्काउंट असतो 0.1 सेंटीमीटर. कारण की आपण जे स्केल वापरत असतो किंवा लॅबमध्ये जे स्केल असतं त्याच्याने कमीत कमी 0.1 सेंटीमीटर मोजता येतं. आता सपोज दॅट रिडिंग्स आर 15.2, देन say 15.3, then 15.4 and 15.3. अशा काहीतरी रिडिंग आलं. सपोज these are the readings, centimeter, centimeter, centimeter. Then find the most probable value. Means we call this as a mean value. So find mean value. Then its mean will be 0 and 46 and divided by 3. So this is 15.33. This will be the mean value. So this is the mean value. Means take addition and divide by 3. it will be 15.33, and this mean value is also called the most probable value. म्हणजे लास्ट आपण लेक्चर मध्ये ते शिकलोय की मीन व्हॅल्यू किंवा त्याला मोस्ट प्रॉबेबल व्हॅल्यू असं म्हणतात. सो in this reading, this 15 is a certain number, or these two digits are certain, but we are not certain about this 33. And 1, 5 and 3, these numbers, these digits are called as significant digits. Now why we do not write these 3? Because least count of the scale is 0.1. When least count is 0.1, then we write only 15.3. When we find average, then that average value may give number of digits, but we delete next digits, remaining digits, and this 1, 5, 3 is called as are called as significant digits, or they are significant figures. Now there are also some rules for the significant figure. Means if this number, suppose this number is greater than 5, then this last significant digit will increase by 1. म्हणजे समजा हा लास्ट जो नंबर 5 पेक्षा जास्त असेल तर मग आपण याला एकाने इन्क्रीज करतो, म्हणजे ते राउंडिंग ऑफ म्हणतात, त्याला राउंड ऑफ करतो आपण. आणि म्हणून हा जो लास्ट जो डिजिट आहे तो अनसर्टन, इट इज अनसर्टन. So in this example 1, 5, 3 are the significant digits or significant figures. So this is meaning of the significant figures. Now if list count of the list count is larger, suppose if there is a measurement and if the list count is larger, then number of significant digits will decrease, and if the list count is smaller, then number of significant digits will increase. Now let us see what are the rules for writing the significant digits. Let us see what are the rules for writing the significant figures or significant digits. So first rule is all non-zero digits are significant. This is the first rule. सर्व जे non-zero digit असतील ते significant असतात. For example, suppose 25.23 centimeter. This is a reading. Then this number is four significant digits. This number has the 4 significant digits. 1, 2, 3, 4. Means all these 4 are non-zero. There is no zero here. All non-zero digits are significant. This is one rule. Then all zeros between 2 non-zero digits are significant. Means for example, this 2005.3, there is some number 2005.3 centimeter. Say this is some number 2005.3. Now zeros between 2 and 5 are non-zero. Zeros between these two non-zero are significant. Means here number of significant digits are 1, 2, 3, 4 and 5. So this number has 5 significant digits or 5 significant figures. This has 4 significant figures. Now next rule, if the number is less than 1, then the zeros between decimal point and first significant digit or first non-zero digit are non-significant. Means for example, 0.012. This is number. Some number its unit is ampere, 0.012 ampere. Then in this example, these two zeros are non-significant. Means in this example, number of significant digits or significant figures are 2. Because by rule, this is decimal point and this is the first non-zero digit. हे पहिलं नॉन-झिरो डिजिट आहे. याच्यामध्ये जेवढे पण झिरो असतील ते काउंट नाही करायचे, म्हणजे जेवढे झिरो असतील ते नॉन सिग्निफिकंट असतील. म्हणजेच याचा अर्थ असा होईल की हे जे एक्झाम्पल आहे याच्यामध्ये सिग्निफिकंट डिजिट्स किंवा सिग्निफिकंट फिगर जे असतील ते 2 असतील. देन लास्ट रूल इज zeros to the right of the last non-zero digit are significant. Means suppose that we write here 1.20 and 0, and if this is centimeter, what is rule? The zeros on the right side of the last non-zero digit. म्हणजे हा 1 आणि हा 2 हा लास्ट नॉन-झिरो डिजिट आहे आणि याच्यानंतरचे जेवढे झिरो असतील ते असतील सिग्निफिकंट. दे आर सिग्निफिकंट. सो देयर विल बी 4 सिग्निफिकंट डिजिट्स इन दिस एक्झाम्पल. तर या एक्झाम्पल मध्ये 4 सिग्निफिकंट डिजिट असतील. नंतर याच्यात तो रूल बुक मध्ये आपल्याला दिलेला नाहीये, बट इफ some number is written like this 1.6 into 10 raised to minus 19, then this number is a 2 significant digit. It has the 2 significant digits. Means there is no need of counting this power 10 raised to minus 19. Just count this 1.6. So there are 2 significant digits in this example. So this is meaning of the significant figures. This is meaning of the significant digits. Now let us see one example which is given in our book, which is based on the significant digits. Example is on page number 15, and it is very simple example. Example number 15. It is example number 15, and it is given on page number 15 of our book. Now let us see this example. Write down the number of significant figures in the following. Means we are given some numbers and we have to write the significant figures. So I will write first number, and this number is 0.003 centimeter cube. This is 1 centimeter square. Now in this number we apply third rule. According to third rule, if number is less than 1, the zeros between decimal point and first non-zero digit are non-significant. Means just count this number 3. So this is 1 significant figure. So significant figures in this example first is 1. Then second example it is 0.1250. This is also less than 1, but here there is a 0 after this 5. This 5 is the last non-zero digit, and therefore number of significant figures will be 4 in this example. Similarly, there is one example 6.4 into 10 raised to 6. 6.4 into 10 raised to 6. We use this rule, and there are 2 digits here. So that's all for today's lecture. And also for 1.9 into 10 raised to minus 31, it will be 2 answer. So that's all for today's lecture.